Okay, so in the last class, we looked at transactions. Basically, we looked at the concepts of a transaction, and we said that a transaction is a statement, a series of statements, which a programmer has to basically decide what is the start and the end of his transaction. Okay, so we also looked at what can happen when we do a commit and a rollback. But just to emphasize my point, I'll show it to you by running code. Okay, so we said that when we do a commit statement, basically the entire SQL statements that we make up to the commit point gets committed, right? Gets into the hard disk of the database. Okay. And when we do a rollback, whatever was there in the buffer to that point of time is no longer made durable into the database. Okay. That means the data that we have kind of inserted will be shown to us temporarily, no doubt. But when we do a rollback, whatever data is there is eliminated or removed from the database. Okay. So rollback to preserve the consistency of data when we have a problem and we don't want that data to be actually inserted into a table. And that is a programmer's responsibility. Okay. Notice also we put the observable external write after the commit statement. So we discussed all of this in the last class. So I won't do the entire thing again. I'll just show you how this code runs. Okay. So here we have 3 insert statements with the date that we're inserting into the table that I've already created. Okay. If everything goes through correctly in these insert statements, we are asking the database to commit our data. Okay. And then we are saying print out the fact that it has committed. Okay. So this is what we are printing out, transaction committed. But if there is any kind of an error when we are inserting our data into a database, we don't want that data to be put into the hard disk of the database. So we want to do a rollback. So if there's an exception here, which basically means there's an error over here, we go to this part of the code and we roll back. So let's run this and get a concept better. Okay. So initially we'll see that there is no data in a database. So let's select star from a date because that's my table name. Okay. There is nothing. Okay. So now let's run that snippet of code that we have and see whether it commits, if there is everything going through smoothly. Okay. So we're just inserting data into this. So let's run this code. It says the procedure is completed successfully and it says the transaction has committed. So if the transaction is committed, then we expect the fact that the 3 tuples that we have inserted into our database is there. Okay. So which 3 tuples? We want today's date. We want a date of October 2023. And again, we want today's date with their first attribute showing 1, 2, and 3. Okay. So this is what we expect. So let's check this out. Okay, so we got our 3 tuples. So we know that everything went through smoothly or correctly. Okay. So now what we will do is we'll delete everything from our database. Remember I said that we cannot say delete star from a table name. So let's see what error it gives us. Okay. It should fail. It should tell us that there is some kind of an issue and we cannot do this, right? So it says invalid table name because it's trying to take from as your table name. We said that we don't have to put in star, right? So let's run this. 3 rows deleted. Let's commit to actually see that the 3 rows are deleted. And now we will run the statement to see whether there's any data. Okay. There's no data into our database. So now let's run the snippet of code again and force an error. Okay. So I know that there is no month called ONT. So because there is no month called ONT, while inserting this tuple into our database, it will fail. So because there's an error, it will go to the exception part of it. And I'm saying do a rollback. Okay. So I should have no data into my database if we reach this particular statement telling us that transaction failed to commit. Okay. So let's run this. Okay. It says PL SQL procedure successfully completed. It tells us transaction failed to commit. Okay, so let's run this and see what data is in our database. We have no data into our database because the rollback didn't even put the first statement that was there. Okay, so to see the first statement that was there, we had changed this to ONT the last time we ran it. This was the first statement, which was also not shown to us into our database because the entire transaction that we have had got rolled back. Okay, so that's a point we need to understand. When we do commits and rollbacks, we can decide where to do a commit and we can decide when to do a rollback. Okay, let's look at more things. So we saw this one. Let's look at this. I'd also told you that there are something called save points where we can decide how much of data we want to keep into our database and how much we want to roll back to. So we can roll back up to a particular save point. Okay, so this is what we will do whilst running it. Save points are useful when a single transaction basically contains many SQL statements. Okay, and we don't want to roll back to the entire beginning. Like in the previous slide that we went to, when there was an error over here, okay, we even rolled back this statement. This particular statement also got removed from our database, and that insert statement with once is date was not there into our database. So let's say we want to keep or retain the first one, we would have to keep a save point over here after this statement. Over here, we would have to keep a save point and say roll back to that save point. Okay, so that's what we are doing in this particular piece of code. Okay, so let's run this and get a concept of save points also a little bit understood. Okay, understood better. So this is what we are doing. Let's see if we have any data into our database. Since the last statement that we executed did a rollback in our previous piece of code that we ran, we should have no data into our database. Okay, so let's verify that before we start executing. Okay, so let's run this. And we have no data. Okay, so we're starting with a fresh plate. Okay, so we'll insert into the table. My table name is basically A date. So let's continue with the same table name. Okay, and after I insert the value 4 and sys date, I have a save point, which I call save point S1. This is a label, so you can call it anything that you want. I'm calling it S1. Then I insert another tuple and I have a save point S2, and I insert a third tuple. Okay, and I'm forcing an error over here because there's no month called 15. Okay, there's no month 15 number. We only have up to 12. So this is going to fail. So when this fails, we have an exception. So I will come to this part of the exception. Okay, and I say roll back to save point S2. So I roll back up to this point. Okay, that means I have my tuple prior to that saved in my database. So I will have whatever data that I have actually inserted previously, which was correct, to be saved into a database and gets committed into a database. Notice where I put the commit. I put the commit here. Okay, so I roll back to this save point S2, and then I say commit whatever is there into my template, memory template, make that durable onto my database. Okay, so let's run this. Okay, there is some kind of a compilation error. There is a problem with the statement, and it is because of this. Okay, let's put this. Remember, I cut and paste, so we could have had some characters that do not get put in correctly into Oracle. We've gone through this before. So now let's run it. It says procedure successfully completed. Okay, I have not put any DBMS output statement, so there is no visible external write. We can check our database. Okay, So let's select a data from a database and see how many tuples get inserted. Okay. We should have 4 and 5 because we said save point S2. We went up to save point S2. Okay. So let's see that code again. We said when others roll back to save point S2. So that means save point S2 is this point. So these two statements which were there in the template got committed. Okay. So this is how we can use save points to control what data we need to enter a database. If there are a series of SQL statements that we have and we want those to be committed and we want certain ones to be rolled back. Okay. Okay. One more point we'll look at is we will do all this in detail a little later, but just to give you an introduction of why we need to have certain things into our system. Okay, so let's quit from here and I will just show you something else. Okay, I have an SQL Plus window. I want two such SQL Plus windows because I want to run two transactions concurrently, and you can see them better via this. Okay, so let's run another SQL. Now, what we're going to do in one of these SQL statements, we know that we can run transactions concurrently. We said that that's the purpose of having concurrency in a database to improve our performance. So I have a table called A. And I have certain values into that table. This is F1, column F1, but it's a character. Let's see what describe A. Okay. It's a character. So a character will only show you one column. Okay. That's why that F1 is not shown to you. And my second one is a number. So I have some data. We'll play around with this data only. I won't do anything more. Okay. So let's look at the statement that I have asked to insert into the database. So I say update A, set F1 equals A, where F1 equals 2. So I have 2 over here. So I'm asking it to set it to A. So when I run this, I should have basically A, 1 and 1. Okay. Let's see what happens. Now, in transaction B, I'm just going to say select star from A. Okay. So this is my two transactions executing concurrently. Okay. Let's shorten this window so you can see both. Okay. So one row got updated. Fine. We said update A, set F1 equals A, where F1 equals 2. It got updated. Let's see data. Okay, if it actually got updated. Fine, we got this correctly. Let's look at what happens in our window B. I'll do the same thing here. Select star from A. Okay. Notice one thing. This particular transaction has got my earlier value that I had. It has not got this new updated value, but where 2 was changed to A. Okay, so my value is different here. The reason for this is transaction T1. I'll call this T1 and I'll call this T2. Okay, so transaction T1 over here, that is on my first SQL on my left hand side, took a lock on the table. Okay, and wrote on the table. So what we're saying is transaction T1, which is on my left-hand side, took a lock, changed the value of 2 to A, okay? And it still has the lock on it. Transaction T2, which is on my right-hand side, read the table A, but did not get the updated version, okay? So it is reading the data of the database which was there prior to when transaction T1 changed the value. Okay, that's why we got 2 and 1 over here. Okay. So when can see this particular transaction T2 see the updated value? Okay. So it can happen when we commit. Okay. So when it does a commit, obviously I'll get the same value here, A and 1. But now when I go to transaction T2, I will get the updated value. Okay. So this is what happens when transactions run or execute concurrently into our database. So they take locks and one transaction cannot see the other updates until the lock is released and things like that. So we will look at all of this when we are looking at concurrency. We will look at one more thing just to make things, I shouldn't say more, but we to know what we're going to be looking at into our data. Okay. Now, I'll clear this so that we don't get confused of what. Okay. And we'll start with a fresh slide. Okay. So over here, we know that our values now are A. Let's see our values. So okay, and I do the same thing here. And I get my same values. Now I'm going to update this table again. So I say update A, set F1 equals B, where F1 equals A. Okay, so it's trying to set F1 equals B, where F1 equals A. I know it's possible it can do that because I have a value A. Okay, and it is going to do that. It says one row updated. Let me see whether it has actually updated it. Okay, it has updated it. Correct. So now let's come here and let's try to update this particular value again. Okay. So all I'm saying is update A. Remember I have A over here. So I'm saying update A. A is my table basically over here. Set F1 equals 1, where F1 equals A. I have an A here, right? So let's try to do that and see what happens. Notice nothing is happening. It is waiting. Okay. It is waiting because this particular transaction T1 on my left hand side has taken the lock on the table. Remember, we took the lock when we talked about locks in the previous, just a little bit while ago. Okay. The same thing is happening over here. This is trying to do an update. So when it's doing an update, again, it will try to grab a lock on the table A, but it cannot take that lock because the lock is already given to another transaction. So it is waiting. And for how long will it wait? It will wait until transaction T1 releases the lock. Okay. So when will T1 release the lock? When it does a commit. Okay. So now when it does a commit over here, the moment I did that, this is what happens over here. It managed to do something. It tried to update it, but it cannot update it over here because this value became B. So there is no row where F1 is A because F1 just got changed to B. Okay. And now I can do whatever SQL statement that I want over here. Okay. So this again will fail, but it can, because there is no A, right? If I do an update over here and I see what statements it has over here, let me see the select statements, it should have a B over there. So naturally, this particular statement over here, update A, set F1 equals 1, where F1 equals A, is going to fail. Okay. Correct. So these are the issues that take place when we hold locks on a table. Okay. So we need to be careful how we run statements, and we can control what we want to do with the database by using something called transaction isolation levels. So we will look at this also in subsequent classes after we look at concurrency and how concurrency is maintained or handled by the DBMS. Okay. So basically, we have looked at concepts of transactions, the execution and things like that. And we also said that an application has a begin transaction. We saw that statement in our code, end statement, and between that there are reads, writes, okay, or updates or selects, so whatever, okay. But the database only looks at reads and writes and aborts and commits. Okay, so this is what we are looking at. So the application sends its SQL statements to a transaction monitor. Okay, and the transaction monitor has modules basically to manage a transaction as it basically processes it. Okay, so as it goes through various stages, the duty of the transaction monitor basically is to see that the progress from one stage to another is done where each stage does its own processing in a successful manner. Okay, so once everything gets performed correctly and the transactions get executed correctly, okay, it gives it to the execution manager, which is an execution engine. The results are sent back to the application. Okay, so the transaction manager basically controls and coordinates the execution of transactions within the database. Okay, it performs multiple tasks to initiate the transactions. When we say initiate the transactions, it would mean scheduling the various requests that are there. Okay, so it needs to synchronize the various transactions, their executions within the database. Besides that, with other transactions that may come from another transaction monitor, if that's a global transactions. Remember, we have distributed databases also. So transactions could be local transactions could be global transactions. So the transaction manager needs to schedule all these in such a manner that you get the property of isolation. Okay. It also needs to coordinate with the operating systems. Okay. It needs to coordinate inter-transaction communication if there is. It needs to handle your commits and your aborts. Okay. So all this processing is handled by your transaction monitor. Okay. So right from initiating the scheduler, okay, to recovery, or I should say initiating the schedules for a scheduler, which will decide the order of execution within a transaction. Okay. It also needs to look at what happens if there is an abort. Okay, so if there's an error, the recovery manager will step in and decide what to do with your aborted transaction, how to handle it. So we will look at all of this in the subsequent sessions. Okay.